Sometimes, like I told you, they're very simple ones. X negative 8 equals 12. I still want to clarify everything in this problem for myself. I want to make sure I see what is actually there so that I'm not just letting things slide, making those silly errors. I know I have 1x here. Well, if I have just a 1, I know that it must be positive. Go ahead and show yourself that sign. Okay, on the other side, I have a positive 12. And I want to also remind myself that I have two sides to this equation. I want to show that I'm splitting it into the left and right. So I can kind of remind myself that once I cross this equal sign, that's about the opposite operation, okay? Can I put these together? No, one has an x, one doesn't. They're not like terms. This guy's already by himself, so each side is simplified. This is what an equation is supposed to look like. So let's go ahead and solve it. Let's solve the mystery. Find this missing answer, okay? That's why we solve equations. We simplify expressions. So once we're here, we need to get this alone. Well, we know a number next to a variable is multiplication. And we know that this and this we're trying to combine, so that's a combination, okay? I need to get this x by itself by the time it's down here. So who's going to disappear first? Remember, we're going backwards PEM.C, SCADMAP, okay? Clearly, the combination has to go first. How can I get that negative 8 out of the way? Well, the only place it can go is to the opposite side. So let's use the opposite operation to get it there. Well, what's the opposite of a negative 8? A positive 8. They're going to battle themselves out. Nobody wins, they're gone. It's a 0. That side's finished, okay? But since this is an equation, if it was equal to start with, and I take away or I give something to one side, I got to do it the same thing to the other to keep it balanced. So I want to make sure this step is equal and put a positive 8 over here as well. Well, these guys are able to combine, okay? They're even on the same team. So since they're both positive, they're going to join, and that's going to be a positive 20. Well, this is still going to be equal to whatever's on the left side, which is positive 1x. Now, using some common sense, just like when we had $1 was $1, if I have $1, that would be $1. Well, I have 1x here, and a positive could really just be a 1x, because that's what we know is why we put the positive there in the first place. And if we have just 1x, that could be x, so kind of reversing what we from where we started, we know we have our x by itself, that's equal to the positive 20. All set. All right. Now, we don't always see ones this simple, and we don't always see ones with just combinations in it. So let's take a look at one with multiplication in it. If I have 5c equals 20, I know I'm going to cut it up, make it into a left and right side, the opposites of each other. I know I'm going to go ahead and show myself that that's a positive 5c, and this is a positive 20. And I recognize by now, okay, it should be good enough, that this is multiplication there. Well, I need to break this apart. I need to divide it so that I can get c by itself. It almost answers it for you. How am I going to reverse that multiplication? I'm going to divide. And I'm going to divide by the exact same number. Okay? Because if I were to divide by something else, okay, I'm actually not going to get what I need there. I need this to be our old friend 1. Because 1c is the same as just c. Okay? As long as it's positive. And positive 1c is the same as 1c, and 1c is the same as just c. So that we've accomplished our mission there. Positive over positive, we know that's going to match. That's a positive answer. 20 over 5, 4 times 5, 5 times 1, just like canceling. 4 over 1 is 4. And there's our answer. But let's look at this multiplication piece again. If I do 2 times 3, that's going to give me a 6. Well, what's the only way to go back to 2? Okay, if I divide by a negative 3, okay, these guys are both positive, okay, 6 divided by negative 3 would actually be a negative 2, because these signs don't match, okay? So what do we want to divide by to get back to our positive 2? We have to divide by positive 3. So whatever we are multiplying by, that's what we divide by, or vice versa. If we're dividing by positive 3, we're going to multiply by positive 3, okay? Because we know that those are the opposites of each other. But keep that sign the same when you're doing the opposite of multiplication or division. Now, sometimes they have both of these operations, both multiplication, division, and combinations in it. So let's take a look at a little more difficult problem. If I have negative 8b, negative 6 equals 26, I know this is a positive 26. Let's go ahead and account for that, and let's separate it into 2. I can't simplify either side, so this is a gift. They gave it to us already simplified. We're ready to go right to an equation now. What do we think? Opposite operations, if you remember. Well, I see right here that that's trying to multiply. And I know I would multiply first, so this would be a number trying to combine with that. So I know right about here is my combination. Which one's going to go first? Well, if we're doing the opposite of the operations, SCADMEP, going backwards, we know that we're going to get rid of the combination first. Where's this combination got to go? This -6? The only choice is to the opposite side, the right side. Okay? Could come from the left to the right. The sides don't matter. Just make sure you go to the opposite. So I'm going to use a +6, and I have to stay equal, so I have to use a +6 over there. Well, these guys are going to battle out. Nobody wins. They're not there anymore. It's over here now. +26 and +6 make a +32, and the only thing left on the left side is -8v. So here I am. I knew this was multiplication. I'm going to go ahead and divide. What am I going to divide by? The exact same number. Okay? Because the division is the opposite of multiplication. I don't need to adjust the numbers. So -8 got to be equal. So I do -8 over here. Well, there's my form of 1. 1v, and what kind of 1v? Positive, because they match. Positive 1v is the same as just 1v, which is the same as just v. Mission accomplished on the left side. All I got to do is simplify this out. Do they match? Sure don't. 32 and 8. Maybe I say 16 times 2 this time for 32. Maybe I say 4 times 2 for 8. Well, there's a form of 1 that I can simplify out. 16 over 4, maybe I say 8 times 2 and I say 2 times 2. There's a 2 that can go. And even for my 8 times 2, I could say 4 times 2, 2 times 1. There's another match. And somehow or another, I'll always get to that 4. Now, if I'm good, I use 8 right from the start. I go directly to the 4. Okay? Use the biggest factor you can. The greatest common factor is always going to be the quickest. But it doesn't have to be used. You can still get there. Okay? And my answer is?
Daddy.
And my answer is v equals -4. Now, still very minor compared to what you might encounter. So let's take a look at a really serious problem here.